introduce yourself, because I see Robert first time actually as well. So then, Robert, stage is yours, or seat is yours, and everything else is yours.
Yeah, thank you, Diana, for having me here at Alaska, and thank you, Max, for organizing this. Yeah, I'm Robert. I'm going to be talking about our tool, Getdeck Beiboot, which is about developing on ephemeral cloud-based Kubernetes clusters. So this talk will be kind of twofold. I'm having some slides giving a very high-level overview about what actually is an ephemeral cloud-based Kubernetes cluster and why we want to use that. So maybe if you know about that stuff, this will be known to you. This might be boring to you. Maybe you don't know about that, then it might not be too deep or a little bit of overwhelming, but either case, don't worry, there will be a demo afterwards of Beiboot, which might be exciting or maybe not. I'm interested to hear. So yes, as I've said, I'm Robert. I'm a software developer and DevOps engineer at a company called Blueshoe here in Munich, or actually now we are a remote company. We actually want and do develop on ephemeral cloud-based Kubernetes clusters. And we also like to develop tools that make it possible and then make it convenient to work in that way. So I actually don't like agendas in opposition to Basti. I just addressed the big pink elephant in the room. You might be asking yourself, what the heck is Kub'rin a breeze? And I'm just here to not being able to answer you this question. But the quote, obviously, most of you, everybody knows about naming things in computer science. So we just went ahead and asked ChatGPT to give us a fancy title for the talk and make it sound like Mark Twain would. And now we're stuck with Kub'rin a breeze and need to run with that. So there you go. And also the second part, maybe more interesting to you, of the title, what the heck actually are ephemeral Kubernetes clusters? Because maybe I'm wrong with that, but I don't think this is an actually well-known concept yet. If we look up the word ephemeral in the dictionary, of course, we get short-living and non-durable, and that's exactly what we're after in our development setup. And I have another great quote from you that probably no one knows. I would be very much surprised because it's from one of our developers, who said, "I'm not attached to my setup. I can throw it away and easily provision it again." He's attached to the service he is developing, not to the kind of dependent services he needs in his development setup. So he doesn't need to maintain this. I'm going to work on the service. Oh no, my database doesn't work. It's kind of needed for that service. He doesn't want to care about that. And if he messes it up, well, he can throw it away, spin it up again, and work with that again. So some criteria for an ephemeral Kubernetes clusters could be, I want to easily and quickly provision a full setup for a short time to achieve a high dev prod parity, to actually have kind of this shift left model. I want to see problems first. And in our experience, this is when we actually do develop on Kubernetes clusters. Devs need to be able to start from a proven, consistent baseline. So if I'm working on a feature or if I work on a bug, I need to solve this. Maybe my path is not actually quite straightforward, but I have to try out this and that and made a lot of changes to my setup. And now I'm kind of in the position of needing to know what was my path, what do I actually need for this bug fix. I need to roll back all those changes, which means I'm making more changes in the hopes that I'm getting to the state back where I started from. It would be much more convenient if I can just say, well, throw this cluster away, spin me up another one from where I started, and now I can try out the path that I think is right. Of course, if I do that, if I spin up clusters and throw them away, I can do that all day, but then it kind of means I always have to start from that baseline, which also sucks because maybe I want to keep my changes to work on that feature again, maybe next week. So I want to be able to quickly and easily store and restore the cluster state. I'm working on a feature. Maybe I've made some changes to the database schema, maybe also some kind of from my manual tests. I want to keep that data for next week, and I can keep my cluster running. If it is running in the cloud, it will cost quite an amount of money. And so, of course, it saves some cost there if I'm able to say, well, store that state, remove that cluster, and next week I can easily spin it up again and pick up where I left off. Of course, we can also think about some CI scenarios where this is actually a good solution. And what I want to leave you with on this slide is the pet versus kettle analogy that you may have heard when talking about traditional virtual machines versus Kubernetes nodes. the pet and the kettle. And my local or my dedicated Kubernetes development setup is the pet in this analogy. So this is a really precious thing to me, because if it doesn't work, I can't do any kind of development work on my machine. So I need to maintain that it is always running. And with an ephemeral cluster, I'm more on the kettle side, where I'm like, well, I don't really care about my setup, as our developer said. I don't care about that. I can throw it away. I can spin it quickly up again. Now, I'm quickly going to talk about why do we actually want to run our cluster cloud-based or remote. I'm using those interchangeably. I could just use Minikube or K3D or any other provider on my local machine. We as a company kind of found those 5 points of flexibility and scalability, of improved collaboration, of consistent development environments. Maybe you also see some increased security and reduces in cost. Of course, depending on your setup, those factors may vary, but what it boils down to me as a developer is I'm not restricted by my local machine. So, of course, I can't run a huge setup there because it just grills my laptop. And as a DevOps engineer, where it is maybe my job to help other developers spin up the local Kubernetes cluster on their machine, which can be quite the challenge in a remote setup, it is much more easier to go ahead and say, well, this thing lives in the cloud, I can directly access it, I can share the Kubernetes config or give you access to that cluster in however way that is needed. And if you have a problem with that, if we need to fix that problem, I can work on that easily as well. So 2 major pluses for me as a developer and as a DevOps engineer. So now I'm going to talk about solutions. I've called it for Kubernetes-in-Kubernetes clusters. And now you might think, why do we want to run Kubernetes in Kubernetes? Well, the answer, of course, is speed. If you think about it, if I'm going to spin up a development setup for you in Kubernetes and I need to do it on AWS or some other cloud provider, this is bound to take some time. No matter how quick I am with that, no matter how much routine I have, I need to wait until AWS has spun up this cluster and it is actually usable. So it would be much more easy if I already have a dedicated cluster, a host cluster, so to speak of, where I can provision virtual clusters inside there and give you access to that. This, in theory, should be very, very, very much quicker, because the worst case that can happen is that the cluster needs to scale. We might have a node autoscaler in there, so we need another node. This takes a couple of minutes. Okay, we can wait that, and then your setup is ready and up and running. And we kind of know about 2 solutions. If you look around in the internet, you are bound to find vCluster. It is very prominent there. And of course, our tool, Getdeck Beiboot, which is unfortunately not so very much known yet. And we kind of found a handful of other projects which mostly don't seem to be maintained. So I don't know why they aren't maintained anymore, but those are kind of the only 2 solutions we know. If you know any other tools, well, please get in touch with us. Of course, it might mean we're just missing out here. vClusters, as a quick overview, achieves this by providing virtual clusters in regular namespaces, but the actual workload you deploy in your virtual cluster is run on the host cluster. So they need kind of a syncer component that synchronizes your workloads from your virtual cluster onto the host cluster. And they are able to achieve multi-tenant Kubernetes with that, actually also in production, which they advertise, which is a great thing. On the other hand, Getdeck Beiboot, our tool, is running fully isolated virtual clusters, meaning your workloads run only in your cluster and not actually on the host cluster. They're not visible on the host cluster. And with Beiboot, you can absolutely easily and quickly create and delete remote clusters. And the very nice feature, I can easily store and restore the cluster state, which we call the shelf feature, which is absolutely relevant for me as a developer. So yeah, this was kind of the high-level overview of what are ephemeral cloud-based clusters and why we want to use them. And now I want to show you, that's the Beiboot in action, how we can use them. So what I have prepared is a little script for me, and is this terminal. I hope you can see this. Is this large enough? Awesome. And for you people over there, can you see this, or do you want to change your position? Awesome. So I am here in my host cluster. I have the Beiboot CTL installed, which is a tool for me as a DevOps engineer. Yeah, well, this is not the best formatted output on that screen, so maybe we're gonna do that full screen, which is barely better. The command I've run is Beiboot cluster ls to kind of list all those clusters I already got here. I have a test cluster from the 4 that I want to delete here. So let's say I want to work on a project that I'm gonna call spacecrafts. I run the command Beiboot CTL cluster create, give it a name called spacecrafts, and gonna provide 2 flags here. I want to provision 3 nodes, and I want to have a port forwarding, so port 8080 on my local machine to port 80 in the development cluster. I just run that. We see a nice little progress bar here, which is maybe not going on in the most consistent kind of way, but we should be finished right every second right now. Just have to wait a little bit. We are at 71%. Beiboot state is running, and it's ready in about 21 seconds, which is absolutely amazing. We can see the cluster is here. It is called spacecraft. It is up and running. We can look at, we are still in the host cluster, at what is actually running in this cluster. So in the namespace Getdeck, we installed the Beiboot operator, which is really the relevant component here, which is actually picking up the cluster name we created and the parameters, the specifics, and is doing the actual creating part. What we are running here is a K3s Kubernetes cluster. So we achieve Kubernetes in Kubernetes by running K3s in a Kubernetes cluster. We can also see there's another namespace called Getdeck Beiboot spacecrafts, which we see there is our server and our 2 agent nodes running in there. So we have achieved now in about 20 seconds, in about 21 seconds, to provision an Kubernetes in Kubernetes cluster. What I can do now is, as I want to work on that cluster, is to run Beiboot CTL connect with spacecrafts. And it says I'm missing an S. That was just a test to see if you paid attention. And I see that I probably didn't clean up my test from before. Yeah. So I have to say this is mostly still in a closed beta testing, or most of those features. So we are bound to see some minor issues of those. But we should be able to connect here. I'm getting a name of a Docker container, and I really should have cleaned that up before. I'm sorry about that. Let's just pretend that never happened. I've run Beiboot CTL connect spacecrafts, and I'm getting here the output. I can now run kubecontrol with a path to a kubeconfig file. So what actually happened is that the kubeconfig got created and get copied to my local machine. As I don't want to run this command all the time, I'm opening up another terminal, which is very small. I'm gonna export the kubeconfig, the path that I just copied. And now I am actually on my development cluster and can work with that. So if we look at that, what kind of pods do we have running in there? Not much going on. We haven't deployed anything in there. We can see the nodes, which are our server 0 and our 2 agent nodes, the 3 nodes that we just provisioned. Now, basically, my job as a DevOps engineer is finished to kind of create this cluster. And maybe we can talk about whose responsibility is it now to deploy the workloads. At this point, well, we really don't really care about that. I'm gonna install some workloads in there. So I'm I've copied something completely different than I wanted to copy. I switched into the spacecraft demo, which is publicly available on GitHub. And I want to deploy that thing in my cluster. I need to kind of manually create this namespace. And this is another thing we still, unfortunately, see this EOF error we need to look into. Again, as I said, this is in a beta stage. So we have a kind of ingenious solution for that, which is, well, we're just going to try again, and now it works. Works like a charm. So now I can run my Helm install for the spacecrafts. It actually complains that the Kubernetes configuration file is group readable and world readable. Of course, again, beta stage. The application has been deployed. We can look at the pods in that namespace. Autocomplete is taking a second right here. And we see we have 2 pods deployed. Our application comes with a Postgres and with the actual application, which is just a small little demo application. You could imagine that you're running much more services in here. Maybe you also have a caching layer, maybe some kind of monitoring, or a bunch of different services that you may not always need, but maybe you have some kind of APIs. You want to see this communication work, or you don't actually have the time or the budget to fully mock your APIs, which would be a shame, but fortunately not every project is that budget rich. So by now our app should be up and running. Yes. Yes, absolutely.
So in production, I would assume that you would really pull the image from the registry from cloud provider. So here, I guess you're building image somewhere locally.
No, if it's K8s, then it doesn't matter. It can pull from anywhere.
Yeah, that's right. So you have this absolutely now is kind of a valid Kubernetes cluster, and you can work with that like with a normal or with the host Kubernetes cluster.
Oh, it's really cool. Okay.
And so we can do everything in this cluster that we can do with quote-unquote regular Kubernetes, or if it would work with an AWS cluster, or with K3s, K3d on my local machine.
Quick follow-up
Yeah.
question. Does the client machine, or let's say dev machine in this case, needs anything else except for the configuration file to connect to this virtual cluster, or does it also require those agents that you mentioned before that run locally in a Docker container, providing port forwarding and stuff?
To actually connect with the cluster, you need, or those containers will be run locally. So
Okay.
Currently you need Docker on your local machine, which handles this, so that the containers
So why
can run.
can't you expose API of the tenant cluster using, I don't know, whatever you have in the parent cluster, like Ingress or something else?
This
It's
may come in the future.
Okay.
Because
Yeah.
it sounds actually like a very cool tool. Let's say you would give developers access to, but not fully.
Yeah.
For example, like our company doesn't trust developers enough to give them access to create new namespaces and to create stuff like that. But we're fully okay giving them, let's say, access to this virtual cluster where they have no possibility to destroy anything.
Yeah, rightfully so.
And if I, for example, create privileged pods in the tenant cluster, will I get the root access to the real node of the parent cluster or not? So privileged pod, my mom should TftC and so on and so
Depends
on.
on how K3s is configured. You can or cannot give that.
Well, that's the question, how K8s is allowed to run inside.
Yeah.
Actually, I wanted to interrupt with this question some time ago, like how is the magic happening? Is there like some lightweight virtualization because you said there is a full isolation, or it's just containers?
Well, basically it's running K3s in this cluster currently.
As a
So
container.
yeah, so it's running, if we switch back to the host cluster. Where did we have this? We see it running kind of, well, this is completely a different one. Yeah, so we see our K3s nodes actually running as pods in this namespace here on the host cluster.
Once it's server-0, right? It's the K3s pod.
Yes, that is the K3s pod, which is
Can you show the config of that pod just well, interesting?
Can I move this question to the end of the talk? So then we finish up the demo and then we get to the... Yeah, absolutely. I understand you. And those are kind of the more in-depth questions. And I guess I get on with the talk on a more high level. And if you're interested afterwards, of course, we can look into those kind of questions. So yeah.
Basically, there is no isolation it's a container. If I manage to escape, which brings to the previous question, I can get to the host somehow.
Sure, in the current state of Beiboot, this would probably be possible. So yeah, we set up our cluster. We have access to our cluster. We are now in our development cluster. We deployed a workload in there. We have seen the spacecraft pods in there that are running. I need to install one thing more. I need to install an ingress controller in here. And I'm gonna look at my ingress, how that is configured. It's giving me this URL, a nip.io. Oh yeah, let's just see if that is accessible in here. And I've said we have port 8080 available. And voila, we see a beautiful 404 page, which is bound to our application because, yeah, well, it's quite the simple one. We have a GraphQL running here. So the GraphQL runner. Let's just see if I can also manage to get some kind of query in here. I want the ID, I want the title, I want the description. We can access the data that is running in here, some kind of a components, whatever a component is. And of course, we can also go into the admin. Oh yeah, I forgot the port there. This can't work. Port 8080, we go to the admin. We unfortunately don't have a super user pre-configured. So we now need to drop into that pod. Let's figure out how this is called with a tab autocomplete, which is a little bit slow at the moment. Yeah, there we go. I want to have this thing. I'm dropping in there. I might see that EOF again. No, I'm lucky. Super user. I'm creating my local super user with a super strong password. Let's just quickly switch back here again. I can log into that application, see my Django administration. Don't want to store those passwords. And I can also go in here and kind of change the state of my cluster. So I can add another component called Kub'rin with the description Kub'rin a breeze. Let's say that this is a power source because it is so powerful stuff. Let's save this thing. It should appear here if I run that query again. And it's here at the bottom. And so now let's pretend we've done some really fancy stuff here. We changed the state of that cluster. And now we kind of want to store and later restore that on again. So what I'm going to do here, this is my development cluster. This is my host cluster. I have another Beiboot CTL command. I need shelf with the name of the cluster that I want to restore. I can also give a shelf name, otherwise a auto-created name will be used. And I can call that thing Kub'rin. Oh yeah. I need to shelf create that thing. The shelf Kub'rin is being requested. Unfortunately, we don't have this beautiful progress bar here. So what we can do is run beibootctl shelf ls. And we see this already running, already ready to use. So this was quite quickly. Now, sure, we just kind of go in here. Maybe we're gonna delete all of those components just so that we destroy the state of our cluster. Yes, I am sure. Now nothing is in here anymore. Nothing comes out of there anymore. And what I now want to do is disconnect from the spacecraft's ephemeral cluster, which I unfortunately forgot at the beginning of the talk. We can actually say, well, this cluster is messed up. We don't want to use it anymore. So we can delete the spacecraft cluster. It might already be gone. It's not there anymore. We can check out the URL should not be available anymore because no cluster is running, no cluster is connected. And now we want to restore that cluster state. So I can, or actually I don't have to type that because I have it prepared. We can just create another cluster, which we're gonna call spacecraft Kub'rin from the shelf, which we just called Kub'rin, if I'm not mistaken. So the only flag I'm using for this cluster create, where previously I specified the nodes flag and the port, I only need the shelf name from which I want to restore that, because all of those parameters have been stored in the shelf also. So I don't need to specify them again, or don't run actually in the kind of case where I'm specifying different parameters and maybe something doesn't work anymore. And now, well, it's the waiting game again. It is already pending. It's at 57%, whatever, 57%.
Did you pay for the shelf clusters?
We actually waited, or what was that your question, to wait?
You pay, when you shelf a cluster, you still pay something for storage.
Oh, yeah. You're storing those, so you pay storage costs, which of course should be mentioned, but which should be very much cheaper than running the cluster. But yeah, you're completely right. I didn't mention that before. Of course, this needs to be stored somewhere in the cloud, so you're gonna pay some storage costs.
Basically, what's happening? It's somewhere in S3, or how do you?
We're using the Kubernetes snapshot API. So there is this thing of volume snapshots and volume snapshot contents, which can be compared to persistent volume claims and persistent volumes. We are creating those, and they are stored. They communicate with the CSI driver, and they are stored in in this case, in my cluster provider.
So essentially, you are running K3s pods as stateful set with volumes, and then backup and restore them, right?
Yeah, basically.
And you're not bound to any particular cloud provider features, right? You only use Kubernetes internal commands and rely on correct configuration.
Yes, so the restriction is that the CSI driver supports the snapshotting API, which not every driver does. You can work around here. I'm working on Hetzner virtual machines. I've deployed Kubernetes with Q1, and we're using Rook with SafeFS to achieve, because the Hetzner CSI driver doesn't support the snapshotting out of the box. But that's kind of what's happening in the background. And so we see the cluster restore took 74 seconds, which I'm kind of disappointed, because my test runs, it took about 35 seconds or whatever. But still, I think this barely more than a minute is a really great result to restore this cluster state. Yes, it did, and that was the end of my talk.
So the line is green.
Yeah, it must have worked. No, that's a super valid question, of course. So we look at that again, Beiboot cluster ls. We want to connect now with the spacecraft's Kub'rin.
You don't need to remove that Docker container this time.
No, because I have run disconnect before. And of course, this is inconvenient at the moment. We will improve this, but I kind of forgot that beforehand. And then you run into this weird issue of, well, you need to know that there is still something connected, even if nothing is there. But yeah, usually that should be your experience. So you have another kubeconfig file here. We're just gonna export this in the other shell. And now we should see that we have the wrong namespace again. That we have our two pods running again, our Postgres and our spacecraft pod. We can look at our ingress. It should not have changed. It would be very much weird if it did. Still has the same host configured, so I should just be able to head on over in this browser, hit F5, and see that we can see graphical again, and actually see our state. For some reason, our new component is now here at the top and not at the bottom. I don't really know why. I don't care what is configured there at the model for the sorting. But now what we have achieved is creating this ephemeral cluster, providing some kind of state. Thank you. It's great to hear such a response, because we develop such tools for our own use case. It's great to see that it might also fit the use case of other people. You have a question?
Are we already in the Q&A?
I would check back into my slides. I probably have some meaningless and shameless plugs in there. So yeah, the kind of how do we actually develop on this ephemeral cloud-based Kubernetes cluster, which I can't really fully address in this talk due to time reasons, of course. You might use no tool playing Kubernetes, which probably sucks. I don't know about you. You might use a tool such as Chiffira, which we all also develop, or like Telepresence, with which both link a local container into your cluster, which is also a really seamless experience, because I can set this up. I just hit one command. I have my local container basically switched into the cluster. I can make changes in my local IDE and have them instantly available in the cluster. So it's absolutely a seamless experience to me. And I don't really realize that I'm working with Kubernetes. I don't have to deal with the build, push, and update cycle. Of course, if you do that, you have tools like Devspaces and Skaffold. But to our need, it's much easier and it's much more convenient to use a tool like Chiffira. And yeah, a little bit of a roadmap. What do we actually have planned with Beiboot? So in the hopefully very near future, we are actually releasing the shell feature. As I've said, this is kind of in a closed beta testing phase. We're working on our own REST API. We want to create a Beiboot service offering, so you can easily check that out. And of course, the aspect developing on ephemeral cloud-based Kubernetes clusters, we want to work to improve that aspect. So we want to build a desktop app, because maybe not everybody wants to work with a tool such as Beiboot CTL, but wants a desktop app would be much more convenient for most developers that don't want to deal with everything that's going on in there, but they can just kind of click around, have their thing available. And we want to more closely integrate Beiboot with our other tools, such as Chiffira and our Getdeck CLI. And yeah, just to wrap things up, we've seen, I hope that you've seen, the Beiboot makes it possible to easily and quickly create, shelve, and restore and delete Kubernetes clusters. I can really easy work with that. We are increasing our dev prod parity, at least that is our experience. We are adhering to the shift left model. And yeah, of course, I'm interested, who of you is already using Beiboot? You're lying. Raise your hand. Why not? What's wrong with you people?
Maybe you can explain the name to the English-speaking guys.
Yeah, the name is from this guy, so this question goes out to you. Well, of course, we wanted to kind of stick in the Kubernetes and nautical kind of stuff and Beiboot. I don't know if that name is available in English.
Yes, it is.
It is. It is.
No, Beiboot.
Beiboot.
It's like the containers you have, like you have a main container, they have separate sidecars. Yes,
Yeah, just a sidecar on a boat. So yeah, that's kind of that thing. Of course, names can get a little bit clunky, but yeah, well, yeah. Getting back to the why don't you use it? If you happen to use it, if you want to try out, please do, and please let us know. We want to be community driven. We don't want to just develop those tools for our own usage to kind of fit our own use cases. You might have different use cases. You might have different experiences with that. Please let us know. You can get in touch with us, of course, through our GitHub projects. We also have a Discord server which is linked in the kubernetes.world URL. Also, if this was a little bit too quick for you, Michael and I, we kind of started or trying to start a podcast where in the recent edition we talked very much about this topic and advertently or inadvertently got into a lot of the details and talked about 1.5 hours about those kind of topics. So maybe if you're more interested, you find more in that, or you find Michael or me afterwards where we can deepen those kind of stuff. So yeah, this was the shameless plug section. Yeah, it's actually the end of my talk. I don't have a thank you slide, so I need to just say thank you. And again, thanks for giving me the opportunity to present this tool here. So yeah, Q&A we have.
I mean, you have a Q&A session, or you already done this question? Because like you had some on the flight. Or...
Well, that depends on the question. Yeah, I think you was first, second, and Alex, you're third.
Thanks for the talk and the live demo. Actually, it was really impressive. I kind of missed the company introduction. So is Beiboot actually a product which is your company offering a future, or is it just a byproduct of something else?
Well, it is also fully open source, so you can just contribute to that, and we are trying to monetize our open source products. Okay. We are making our money. We are a software agency, and this is kind of our work on this side. And yeah.
So a real Beiboot.
A real Beiboot, yeah.
What's the license there of the project? You said it's open source, under which license?
No license yet. Don't make it easy.
I don't know that out of the box, so let's just look in here. Apache license. You had another question?
Yeah, I have a couple of questions. First of all, thank you very much. I really like this concept. So it's just recall me Docker in Docker.
Yeah.
So very first question is from the basic. First time I saw this kind of thing. So to installation, what did you use? The Helm or do you have operator over there? So we can for the installation.
To install Beiboot, we can simulate that real quick. This is our host cluster. It already has Beiboot installed, and I can just run Beiboot-ctl install, which produces a lot of manifests, which I then can apply into my cluster, and I'm done with that.
And next thing, I also like, for example, is it just meant to be for one person? For example, like say my developer is working on one feature, he has tested, and now it's now turned to give the chance to the tester. So can he share, or it is just for the like you cannot share this cluster with others?
Oh no, you can fully collaborate on that cluster however you want, or however your company's policy with that is. So Beiboot doesn't restrict you there in any way. Currently, you basically only need the kube config as we have seen, and well, currently you give that out to any person that needs access to that cluster. Of course, that aspect can be improved, sure, but that's not a restriction we want to build into there.
Is it purely based on RBAC?
What?
RBAC.
Yeah, currently we don't yet work with that, but of course that also is on our roadmap. You're welcome.
Can you please show the declaration of the Beiboot cluster stateful set? Just to see
of the development cluster we
well, basically what you have in the host cluster declared.
So this thing you mean?
Yeah.
We can look at the YAML of that.
So you are running
K8s.
Oh yeah, I'm using K8s, which is really convenient for me. Maybe not for everybody else. I kind of didn't want to do that in my talk, but I think it's a really awesome tool. But
what are the containers that make up the pod?
So you never saw it?
So they run quite some stuff to actually achieve the kind of cluster reset and restore. And we should be running here the K3s server command with the flags that we need.
And those subnets, they are static or you generate them somehow dynamically? Well,
those here?
CIDR, yeah, service CIDR, and so on and so on.
Well, those are the What do you mean?
The cluster CIDs and the service CIDs look like default ones to be used by Kubernetes.
Yeah.
And what else do you have except that port? Nothing. It's not privileged. Yeah, it's just cool. Congratulations.
Yeah. Thank you.
Yeah, I think just a lightweight VM that you run the K3s in. So you spawn a pod with a lightweight VM and then you run K3s inside, and then it's going to be production grade corporate tool.
Yeah.
And how does it? Okay. Very cool.
Okay. Yeah, and so it's actually interesting because we were playing around also with the performance of that on different providers, on AWS, on Google, and on this thing with Kube1 provision on Hetzner, and we actually made the best experience on Hetzner, which also amazed us. Sure, you need to run, or you need to kind of take care of those clusters yourself. We are using Kube1 to do that. But yeah, Hetzner, as you may know, is compared to the others, is like ridiculously cheap also as well. So this really suits our need as an ephemeral cloud-based Kubernetes development cluster.
Should try Exascale. Needs for managed Kubernetes like 1 minute 20 seconds.
Oh, nice. Nice. Yeah, we might look into that. You took notes?
No.
So yeah, then, another question.
Two questions. One is, now Django gives you GraphQL out of the box, or you're using some tool, some plugin or something?
No, we're using a package, that application that provides the GraphQL. So the spacecraft demo, you can actually check it out. It is on our Django Hurricane project located on that organization. If you're interested, you can check out how that works.
Okay. And the other question was, what was the other question? About Hetzner.
Yeah.
What is your opinion about this something one that you said you're using to provision clusters?
Kube1.
Kube1 over Rancher?
I haven't actually tried out Rancher yet. We kind of found this Kube1, and yeah, you basically only have to apply some Terraform, run Kube1. Of course, you have to wait some minutes until everything is ready, but this takes care of all the kube admin stuff and stuff like that, and you have your Kubernetes infrastructure. So it kind of was this, well, let's try this out. Okay, it works good for us. No need to change there. So
that was my question.
Yeah. It might be that actually you find something else more convenient or more suited to your use case, but that kind of was our story. So, all right, now giving the word back to you, or do we just awkwardly transition into the next phase? We just close this slowly. Thank you.